きます。 Hello! This is Taylor from ATAGO here in Japan. Thank you so much for joining our webinar today. Today we will be talking about FreshCut Produce. It's kind of like a little guide to reducing microbial food hazards. So the focused units for today will be the PAL-Hypochlorous Acid, also PAL-Peracetic Acid, PAL-39S, which I don't have today, and then also the PAL-PH. So PAL-39S is for hydrogen peroxide. It works almost the same way as the other instruments, so if you are a hydrogen peroxide user, then you can still watch this video and it should be helpful for you. Okay, so let's go ahead and get started. If you are watching this live, go ahead and put any questions you have in the chat box as we go through the seminar. As your questions come in, I'll take a second and answer them, or you can wait till the end, whatever is best for you. Okay, all right. Okay, so just really quickly going over what is FreshCut Produce. So FreshCut Produce is fruits and vegetables that have been cut, sliced, diced, or cored, and then those are packaged and they go to the grocery store and they're sold as is. So when you go to the grocery store, go to the produce section and you see all of the chopped up lettuce or chopped up watermelon already packaged there for you. That's what FreshCut Produce is. So FreshCut Produce is more attractive than just a regular type of produce because of the convenience. So a lot of the times, especially restaurants, hotels, hospitals, food processors, they like to get these FreshCut Produce because of the convenience. It's already chopped up for them, so they don't have to spend the labor. They don't have to have the equipment to chop it themselves. So it just makes everything go a lot quicker. So when you have that convenience, it does come with some problems as well. So if you have a head of lettuce, for example, as soon as you cut it, the shelf life starts to be reduced. So once it's cut, it's more susceptible to temperature changes. That encourages bacteria growth. As well, cutting just equals more risk for other microbial contamination. So that's why a lot of the times you're told to wash your vegetables before you eat them because of those microbial contaminations that could make you sick. Especially in the food industry, you have to be rinsing off the vegetables and the fruits before sale, so that by the time it gets to the grocery store or to the food facility that will be making them, that they don't already have that bacteria growth. So you may be familiar with some organizations out there like HACCP or like FDA that do give some guidelines for how to manage microbial contamination in the fresh cut produce industry. So my presentation is pretty based on HACCP, but of course you're going to want to check with their official things that they've put out there to make sure that you're following everything correctly. What we'll be focusing on is more of the little handheld instruments for the washing process. So for the fresh cut produce process, you'll see here that there are just in general like 5 main stages. So the producer, or who's growing vegetables, there's going to be an agricultural corporation. Here in Japan, it's obviously Japanese Agricultural Corporation. And then there's the consumer market who's purchasing those, but then they're also going to go to a cut fruit and vegetable supplier, like a separate company that's going to actually do the cutting. And then that will go to the food producer or to the supermarket or whatnot. Then it's kind of broken down into 8 steps within the cut fruit vegetable supplier. So you get the vegetable in, you have to clean it first to get all of the visible dirt and contamination off of it. You'll do just your major large cuts. Then it will be rinsed again more thoroughly. Then it will be made into the fine cuts. Then after that it will be sterilized one more time. And then all of that's drained, packaged, and then shipped out to where it needs to go. So ATAGO's instruments can help with step 1 cleaning, step 3 rinsing, and step 5 sterilization. Okay. So this is a very just general visual aid for you that I found from the International Journal of Food Microbiology. Just so you can, just showing, just so you can kind of see visually the pre-washing part of it will happen, and then the produce will kind of go across the conveyor down into a washing tank that holds the sanitizer. They'll go out, and they may be even rinsed one more time even after the sanitizing agent. So it makes a lot of sense to keep washing the produce and keep sterilizing it throughout the different parts of the process. Just because when you're doing large cutting and then you're doing fine cutting, even between them, there may be different equipment, and that may increase the chance for some microbial growth as well. So that's why those organizations recommend that you keep rinsing at various times throughout the process. So you may work at a FreshCut Produce facility and think, I'm already using sanitizers for washing. Why do I need to measure them? Why do I need ATAGO? Why do I need these little instruments? So just for some information, some of the reasons that FreshCut products generally fail, so they can't get to the consumer end, is really from microbial spoilage, excessive tissue softening, and tissue browning at cut surfaces. So if those are the main reasons why your product may fail, it just makes sense to monitor the concentration of those solutions, especially if you have something like a hypochlorous acid solution. A lot of things can affect the pH and can affect the concentration of that as you're using it and as it's maybe evaporating. So it's good to just make sure that you're at the proper concentration at all times. Even from your initial dilution, you may see some changes in concentration, and that's going to affect your produce in some bad ways if it's not managed properly. So we'll be focusing mostly on microbial spoilage for these handheld instruments, but you can just keep in mind for some of the solutions that are used to prevent tissue softening and tissue browning for fruits and vegetables. ATAGO has instrumentation to monitor the concentration of those as well. For example, there's apples, and they're cut. Apples are known to brown very quickly, and they do to put a solution on apples, like a spray, before they're packaged to delay that browning for when it gets to the consumer. So ATAGO can help with that as well. But just keep in mind that all of these reasons can be avoided by maintaining the solution's proper concentration and pH level. So if you are working at a FreshCut Produce facility, then you're probably already doing step 1 and step 2 as your part of your operations. So you receive the sanitizing agent as a concentrate, and then you're going to dilute that to the proper concentration, and then you may think that you're done from there, but actually just with one more simple step of measuring, you can make sure that that dilution that you make is going to stay the same, and it's going to be at the proper concentration at the time you made it, and then from beyond. So you can know whether or not to put more in, or if you need to change it, and things like that. So it's a really simple thing to just add it onto your process. So before I get into the individual instruments, do we have any questions? No. Perfect. Then I can move on. Just a reminder, if you are watching live, go ahead and put your questions in the chat, and then I will get to them whenever we have a moment. Okay. So here's the ATAGO lineup that I was saying before. Here we have hypochlorous acid and PAL-Peracetic acid. These are conductivity meters. So just because of the nature of hypochlorous acid and peracetic acid, found it's more accurate to measure them with a conductivity meter. You'll see that the PAL-39S in the bottom right for hydrogen peroxide is a regular refractometer. So that's just a different measurement method to measure the concentration of hydrogen peroxide in water. And then we have PAL-pH in the upper right. That's going to be a pH meter. It's actually a lot different than most pH meters in the market. It's more of a droplet style, like our regular PAL series, as opposed to a dip style. And I'll talk a little bit more about the benefits for this type of style over the other ones a little bit later. So in our video today, we will go over how to measure with these two different ones, just because hypochlorous acid and peracetic acid are a little bit more common in the fresh cut produce industry than hydrogen peroxide. So we will just kind of go over those, but just know that PAL-39S is very similar in terms of use. Okay. So this is a very general pH and concentration information page for you. Definitely going to want to look up the official guidelines for whatever hypochlorous acid you're using, or whatever process that you're required to follow in your country or for your company. But just in general, when you're using it as a cleaning solution for fresh cut fruit, hypochlorous acid should be maintained around a level of 2.5 to 3.5 pH, and then usually from 100 to 200 ppm. I did see some literature that showed that even something as low as 50 ppm would be okay, but I think that just, again, maybe depends on what country you're in, what rules you have to follow. Okay. So some things to keep in mind, or additional things that you should know. So these are not the only ways in the world to measure the concentration of your cleaning solutions. There are two other methods. One is titration. That's using chemical reagents and having a nice base knowledge of titration or chemistry to be able to measure. It's more of a chemical reaction-based type of method. Takes a while to do. You have to find a way to dispose of the chemical reagents afterward, so it's actually pretty troublesome. This instrument is actually a lot easier to use because you're just using water and then your sample, which is the solution. So there's no extra chemicals that you have to use or get rid of or anything. That being said, titration, it may be perceived as being more accurate just because it's the first test that was available. But this is going to be this is going to be for something more of a quick check. So it should get you very, very close to titration, but it may not be exactly the same every single time. There is actually a feature on this instrument. We call it an offset feature. So if it gets really close to titration, it should be different about the same amount every single time, which means that there's a correlation. So if you just find out that correlation coefficient, then you just put it into this instrument, and then it will adjust the measurements as if it were reading like titration. So that's just a quick, easy fix. If you are currently using titration and you want to keep seeing those very, very similar numbers, then you can kind of trick your PAL-Hypochlorous acid into reading like that as well. And then we have test strips. So those are like the little paper strips that you're going to stick into the sample. You're going to read a color chart on the box, and then you're going to kind of guess from there which color it is and what the ppm is. When comparing to test strips, we don't really recommend that you base like this number and test strips against each other, just because they are different methods and test strips aren't really as accurate, and they're a little bit subjective. There's things that can go wrong as well, like if the test strips have been expired or if they got moisture inside, then they're no longer viable. So I would highly recommend to use something more accurate and more digital, like this. So a lot of people that have already purchased PAL-Hypochlorous Acid really like it just because it's really quick, easy, and digital. There's not too many mistakes that you can make in there, which you'll see in the video. On that note, there is one thing I do want you to keep in mind. So because they are digital instruments, before you use them for the first time that day, you'll want to do a 0 set. Or it's like a daily calibration. You only have to do it on the day that you're measuring, and you only have to do it once. But when you are doing your daily 0 set, especially when you're using PAL-Peracetic Acid or PAL-Hypochlorous Acid, it's good to 0 set with the same water that you're making your dilutions for. So remember that you have your hypochlorous acid concentrate that comes in, and then you're going to dilute it with some water to make your sanitizing solution. Before you measure the concentration with this, you want to take the same water that you had made your dilution with and 0 set, or like a little calibration on this instrument, and then you can measure. The good news is that if you're doing your dilutions with purified water, then you can use any purified water. If you're doing your dilutions with the tap water at your production facility, then just make sure that you use the same tap water at the same facility to 0 set with. Generally, like across the world, water may be different levels of ppm, so it's good to just kind of give the unit a good baseline by calibrating with the same type of water that you're making the dilution with. If that is confusing in any way, please feel free to put a question in the chat, or we can have a conversation via email later. Another thing to keep in mind for dilutions, if you can, please try to make your dilutions using volume over volume and not weight over weight. The reason is the instruments are actually made and calibrated using volume over volume, so that's just going to help increase the accuracy of your dilutions and measurements on the instrument if you dilute in the same way that we are calibrating our instrumentation. So if you don't do it that way, you may see some different results, but it shouldn't be too much of a deal for you. Okay. So I'm going to pop into the video here. It's really short, but before we do that, just quick question check. Nothing? Okay, moving on. So let's go to the video. So here first we have PAL-Peracetic Acid. So I had received some peracetic acid from our factory actually earlier this morning, and I recorded the video. So I'm just taking some pure water because our office here has pure water, so they made it with pure water at the factory for me. Doing a quick 0 set, and then once it's done flashing, then you know it's done. And then it's good to take a soft tissue and wipe out the water. It is a pretty durable electrode, but try to avoid using anything too abrasive, like a brown paper towel, when you're cleaning. And then you'll take your sample, and then you will take a pipette or spoon or dip it into the solution directly with the instrument, whatever is best for you. The only thing you have to make sure is that you're putting enough sample on the instrument. So I always just make sure to fill up all the way to the edge of the metal part, or like the little well, so that I am measuring enough sample incorrectly. And then you just take a tissue again, wipe out the sample. You can give it a rinse with water again afterward. Then we'll move on to PAL-Hypochlorous Acid. So this is a spray that we have for sanitization of desks here at our office because of the whole COVID-19 situation. But it's really just the same thing, putting the water on, pressing start to turn on the instrument, pressing 0 to 0 set it. Then once it is done flashing, we take a tissue to wipe it out. It's good to make sure that it's completely dry, like all of the water is wiped out before you put your sample on it. Otherwise you might actually end up diluting your sample a little bit more. It's not going to be as accurate after that. Then we have a pipette to take out our sample, put it on our instrument, make sure we have enough, and then press start. And that's it. So as you can see, I think measuring on both of the instruments for 2 different samples took under 2 minutes, so it wasn't really that long at all. I think if you are worried about maybe it being cumbersome having to all of a sudden check the concentration, it's really not. It just takes a couple seconds, and then you're making sure that your concentration is correct and you're following good food safety practices. So what we did was measuring concentration with PAL-Hypochlorous Acid and PAL-Peracetic Acid, but what I wanted to also talk about was PAL-pH. So as you can see, they are very, very similar in terms of design, and the sample stage is a little bit different. Reason why is PAL-pH, the electrode, you can see kind of, I'm hoping you can see here, you can see a nice flat durable electrode. So it really measures the exact same way as the PAL-Hypochlorous Acid. You'll just drop the sample onto the meter, press start, and that's it. The only thing that is different is the calibration of the PAL-pH. So what you do have to have are these handy little pH buffer solutions. So if I can get those. So you will just do a quick calibration with your buffer solution. Let's say you're measuring hypochlorous acid, and I said that was around 2.5 to 3.5 pH. There are 3 different buffer solutions here for 4, 6, and 9, but since the range is pretty low, 2 to 3, then you only need to do calibration with 2, with the 4 and the 6. So that only needs to be done like once a week. A lot of pH meters you have to measure, or you have to do calibration with a buffer solution every single day, and that can, 1, make you go through a lot of solution, and 2, just use up more of your time. So with PAL-pH is good because you only have to calibrate like once a week and you're all set. It does come with all 3 of the buffer solutions initially. You can purchase them from us again if you run out, or you can easily get it from another supplier in your country. That's probably going to be more cost effective for you anyway. So this is 4, 6, and 9, but we do have other solutions as well that the PAL-pH can be calibrated with for 4, 7, and 10. So if you're a company that goes by those standards, then don't worry, PAL-pH can do either set. So going back to what I said before, PAL-pH is a different measurement style than a typical dip style pH meter. One of the reasons for that is it's actually more hygienic and easier to clean with this type of style. So with like electrodes, you have to really work to make sure that you're cleaning up into the electrode, but with this, just like with a regular PAL, it's easy to wipe it out and wipe clean. Also makes it more durable because if you drop it, there's no part of the electrode that's going to break off, or if you drop a pH meter directly on the ground, it's just going to go nose down right onto its little glass electrode, and something's going to come off, or something's going to get scratched or cracked. So this is definitely a lot better of an option. Also, with both these types of models, because they're digital instruments, they do have NFC data transfer. So if you have your smartphone, or if you have an NFC reader for your computer, you can actually just give it a quick scan and it's going to dump all of the measurement data into your phone or computer. So that is an extra added plus when you get an ATAGO little digital instrument. Okay, so that is the end of my presentation. Thank you for everyone who is able to watch today. I'll spend a couple of minutes here for some questions if we have them. Do we have any questions? Okay, so if you do have questions, this is your absolute last chance before I end the webinar. But just wanted to say again, thank you so much for joining. We do have a lot of webinars scheduled for some other topics for this month. So if you are interested, please go check out our webpage and see kind of what other things we're up to and what you can learn about. Of course, we are easily contactable at our email address. I have it right here. overseas@atago.net. Anything? Okay, perfect. So we are good to go. Thank you so much, and I hope you guys have a good rest of your day, and see you next time.